Hi guys, happy Monday. Hope you guys are doing good. Hope you guys are having a good Monday so far. I wanted to show you guys our math meme of the day. So here's our math meme of the day. It's one of my favorite movies from back when I was in high school. Mean Girls. Stop trying to make a plus b squared equals a squared plus b squared happen. It's not going to happen. And you guys know just how annoyed Miss Goldenberg gets when people do that. Because you know that you're forgetting to do your whole box, right? And Miss Goldenberg gets really sad when this error comes up because it happens all the time. And it's like, did you forget about the other two parts of the box where you have your AB and your other AB? And then I get sad. So, listen to Regina George, please, my friends. Okay. So, we are doing some matrix operations practice. For the first practice problem, I've just got 3 matrices here. Why don't you pause the video and try out these problems for a quick check-in for how you feel with the matrix operations we went over on Friday. Okay, so at this point you have tried them on your own and you're unpausing the video. So if I want to do 2 times A, that's going to be 2 outside of matrix A. Remember, this is called your scalar multiplication, where you just scale it up. Oh, good. Apparently there's virus and threat protection. That's good, guys. So I'm going to scale it up and make everything doubled. 0, 8, 1. And then I have to do 3b. So I'm also going to do 3 times b. I'm just going to make this a little bit smaller so that I've got a little bit more space. So then I have to do 3 times b, which is going to be 3 outside of the matrix. So it looks like it's going to be 18, negative 9, 6, and 9. And then if I am asked to subtract them, I've got to do my first one minus my second one. Just remember when you subtract to distribute your negative correctly, right? So like negative 10 minus 18, negative 28, 0 minus negative 9, that's going to make a plus 9. We got a 2 and negative 8. So that is your answer for the first one. And this one's like a nice example of, on an assessment, I probably wouldn't ask you to just add them or subtract them. You'd probably have to do a couple things in a row. The next one is A plus C. So if I want to add this matrix plus this matrix, oops, 23 and 2. At this point, you should be screaming at the computer at the top of your lungs. Not possible. Right? Because if you're trying to add them, you can match these guys up. You can match these guys up. But when you try and add this one, there's not another entry on the first row. So that's why it's not possible. Okay, so adding and subtracting, they have to be the same size. Remember, the fancy word for that is order, right? It's rows by columns. Now let's do some more matrix practice. Okay. So we are going to do some matrix operation practice. So some of you guys were asking, like, when I do these matrices, like, do they represent anything or not? Sometimes people use matrices to hold a large set of data. So for instance, if we are looking at the Cubs, the White Sox, and the Cards, I'm going to be brutally honest, I don't know who the Cards are. I know the Cubs and the White Sox, and I'm pretty proud of that, but I don't know who the Cards are. So if one of you guys who knows baseball could comment on this video and tell me, I'd much appreciate that. It also makes me very sad because right now there is no baseball going on, right? No sporting events. It's really quite unpleasant to bring up this pain. My baseball people, I'm really sorry to bring this up. Like, I know, Ben, you play baseball. I'm so sorry, Ben. So let's look at this one. If we want to find the total standings at the end of May, which is total wins and total losses, right? So this is saying, like, after April and May have gone by, we just want to know, like, how many wins, how many losses. What that's asking us to do is add the matrices. So if I add my matrices, my Cubs looks like they've won 27, but they've lost 27 as well. Come on, Cubbies. For my socks, it looks like 28, 29, 30. It looks like 32 and 22. Socks are doing pretty good. This one's 29 and 27. Okay. And remember, the first one is wins, second one is losses. So sometimes people will record data in this way. So that's just like one nice application of a matrix. This next one, people really enjoy this problem every year. At the Starts with S store. This is a store where they only sell things that start with the letter S. So you know that someone who is like really self-centered and their name starts with an S. Like maybe Stephanie started this store, right? So at this store, they only sell things that start with the letter S. So for instance, like they sell shoes and socks and shirts, all kinds of things that just start with the letter S. Okay. Now here's what's really funny. Looking at my rosters, I double check just to make sure I don't miss anyone. We have Serena, Sumia, Sonia, and Sajda, who could be in charge of the store. Their names totally start with S. I didn't see anyone in my third period whose name starts with S. So, kind of weird. Second period seems to be in charge of the store. So they only sell things that start with S. We've got some matrices that have number of shoes, socks, and shirts sold in January and February. And we also have their unit price. So this is actually a really interesting application of matrices, how you could use it in like a store context. The question that we're asked is at the bottom, if you can see it. We want to find the store's total income based off of how many shoes, socks, and shirts they sold in a month. And what's kind of interesting is thinking about like what matrix operation could we use to figure that out. I know I can't add or subtract because they're not the right size, but if we do multiplication, would that work? So I'm writing down the number sold, right? 388. Now I'm thinking about my multiplication rules. This one is 2 rows by 3 columns. The second one is 3 rows by 1 column. So if I want to multiply, remember how the middle numbers have to match up? So I have to do the first one, number sold, times the matrix that involves my price information. Okay. So from here, if I wanted to find how much money they made, I would take, number of shoes times shoe price. Add that to number of socks times sock price. Add that once again to number of shirts times shirt price. So this kind of is a nice example of when you do the matrix multiplication and you do your row 1, right, times column 1, that's going to represent your kind of pink information, 458 times 4850 plus 560 times 575. And then plus 411 times 39. And that's going to be my first row times my first column. When I do the bottom row, bottom column, that's going to represent how much money I have made in the month of February, right? So February, it looks like I have 389 times 4850 plus 511 times 575 plus 388 times 39. Okay, and I'm going to crunch those numbers real quick. I'm going to pause it and unpause it. Okay, so I finished crunching out the numbers, and it looks like my total income in January and February were those numbers there. If I wanted to have my total, I could add those together. So it looks like the total for the 2 months is about $78,398. So that's a nice example of when we can use matrices to represent something other than just like plain numbers that are just random. This is one example. You guys have already seen how matrices can be used to represent a system of equations. They're not always used to represent a system of equations, so just sometimes. Okay, let's see. So the next couple that I wanted to look at, I think these are the last 2 I wanted to do in this video. And then I'm going to have you guys try out the matrix operations quiz just to see where your skills are, see where you're feeling you are. These ones are kind of like the step up from the regular. So these are kind of like the medium level problems where there's like a little bit more going on. And I ask you to solve for x and y. So what this is saying is I took the first matrix, I'm going to maybe call it like yellow matrix. I took a yellow matrix and I multiplied it by pink matrix. And then I got the green matrix. And the question is, how do I solve for x and y? So if I think through how I would normally solve, like multiply this out, I would do like row 1 times column 1 to get that number, right? So if you write it out, we have that negative 2 times x plus 3 times 4, which is 12, has to equal 36. And what's really nice is this one is done in a way where we can be like, oh, I can solve for x, right? It looks like x is equal to negative 12. And then similarly, if you want to solve for y, I'm just going to try and pick a color that's different. So row 2 times column 1 equals that number. So my equivalent would be like 1 times negative 2, or negative 2, plus 4 times y has to equal negative 5. So similarly, we can solve this like regular two-step equation, and y is equal to negative 3/4. So this one I think of as, just kind of going through your regular steps for multiplication, except for I'm telling you what the answer has to be. There's one here that's similar. What I want you guys to do is pause the video and start trying out the problem on your own. Start trying to think about what multiplication would say this has to look like. And then unpause it once you've kind of gotten a start on problem number 4. And feel free to leave the screen up so you can see number 3, right? But try this one on your own and then unpause when you want to check in and see how you're doing. Okay, at this point you've unpaused and you want to check in on how number 4 is looking. So I'm going to try and zoom in. Okay. So for number 4, if I followed multiplication rules, I would say, okay, row 1 times column 1 equals the row 1, column 1 entry. So 3 times x plus 4 times y has to equal 15. If I did row 2 times column 1, that would have to equal 16. 1 times x plus 5 times y equals 16. Now, guys, this is when you get sad, because if we think back to the first one, when we did that, we only had 1x or 1y in each equation. This one is kind of sad because you have x and y in both equations, and you're like, oh my goodness, Miss Goldenberg, it was not straightforward. What's going on? And Miss Goldenberg's probably going to be like, do you know how to solve this? If I put curly brackets, does that maybe make you realize your strategy a little bit easier? We are going to solve like a system of equations. I'm going to do this one times negative 3 to get the x coefficients to match up. So I'm going to have 3x plus 4y equals 15. And I'm going to be adding that to negative 3x minus 15y. Make sure to multiply everything by negative 3. Plus negative 48. When you add, those are going to cancel out. You're going to have, it looks like negative 11y is equal to 48 minus 15 is negative 33. Divide by negative 11. And notice your numbers are working out pretty nicely. It comes out that y is equal to 3. If we know that y is equal to 3 and we go back to any of our equations, right, we could pretty easily say, okay, so if I plug it back into the bottom one there, 3 plus 5y equals 16. Oh, excuse me, it's the wrong thing. If y is 3, x plus 3 times 5 is 15 equals 16. And oh my goodness, I know that 1 plus 15 is 16. I'm feeling really smart right now, right guys? Okay, so that's it for those. I've got some other questions for extra practice. So what I think I'll do is I'll make a second video with these as optional extra practice with matrix operation video. So I'll make this part optional, just if you want extra practice. But what I would first do before you look at that is try out the matrix operations quiz. I'm going to make a little video or a key walking through that, one or the other, and I'll have that posted as well. So first try out the quiz, and then if you want some extra practice, these are mostly word problem examples, or I guess one word problem example. So I have one extra practice problem if you want, just since my video is about to end. Okay, guys, I'll see you later.